Hi, this is Brian Fogarty, and in this video what we're going to do is look at model evaluation of LOGIT and Probit. Actually, just LOGIT. Probit is going to be the same thing, but just LOGIT regression in R. And so in the previous video we went through and I introduced the data that we're using and ran our LOGIT regression model, which is right here. Okay, again, the outcome variable is an employment dummy. And then we have our predictors: gender, general health, that's someone's health status, and then a dummy variable for whether someone's married or not. All right, so in R, when you run LOGIT, at least with the GLM function, you don't get a lot of model evaluation information. Now, some of the stuff we're going to look at is actually kind of silly to look at, but we don't get the output that you might get from, say, if you're using Stata to run this. So from the output, that's a default thing from the GLM function. We do get the AIC right here that comes out. Okay, on its own, the sort of informational measures like AIC, and we'll see here log likelihood, it doesn't really tell you anything because it's only useful really when you're comparing different models and trying to figure out what's the best kind of model to use, which one fits the data best. All right, so if we want to just get the log likelihood, we use the log lick function. So it's log lick, and then we're just going to do model 1 because that's the name of our saved object here. All right, and then we just run that. We get this, our log likelihood value. Again, on its own, it doesn't really tell us a lot. All right, so a lot of people love R squared in linear regression in using OLS. And so if you've taken a course on this, you know this already, but they've created a similar kind of measure within MLE that's called Pseudo Rsquared. Now, pseudo literally means fake, right? And so you can get these Pseudo Rsquareds in other packages. They come, like Stata, it'll just give it to you automatically. In R, it's not automatic, which is probably a good thing, to be honest. There's a number of different ways we can get this, but if we use the PSCL package, there's a function that gives this to us automatically. So we're gonna call this up. We're gonna load this package. So we're gonna do library and then PSCL. All right, and then it's gonna give you a whole bunch of information to tell you who made it. All right, including this warning message. So this is something if you use R, or you're just getting used to R, where it comes up as a warning message. So warning messages usually aren't that bad. It depends on what the warning is. If you have an error message, that means it doesn't work. All right, so warning message, this is just saying that it was built, or this version of this package was built under a different version of R that I'm currently using at the moment. All right, so that's all that means. So if we use the function P and then uppercase R2, so this stands for Pseudo Rsquared. So we do P R2 and then model 1, and we run that. Then we'll get a whole bunch of different kinds of Pseudo Rsquared. The most common one here is the McFadden one. All right, so this is so this doesn't give us the exact value. So E to minus 0.1 just says to move the decimal point to the left 1 decimal spot. So what that means is our Pseudo Rsquared here using McFadden, again there's other ones over here, is 0.1527. All right, so on its own that really doesn't matter. It doesn't mean anything. All right, but people like to have it. Fair enough. Okay, another thing that we can do that some people like to do is compare our model to a null model, right? So this is sort of this is equivalent to doing the F-test in linear regression. And so what we're going to do is we're going to create a new object called model1null, all right, using the assignment operator. We're going to do GLM, our outcome variable here, which is employment dummy tilde, and then we're just going to include a constant, so 1. All right, and then we're just specifying that we're using, again, the binomial family, and the link function is LOGIT. Okay, and then the data that we're using as well. So comma data equals data. Again, that's just the name of the data. You can call it whatever you want. All right. So let's just run that. Make sure that that works. Okay. So we got no errors from that. And then we could just do an ANOVA test here between the two. So we have model.1 null, comma model1, and then the test that we're doing is chi-square. All right. Okay, so we're looking down here. This is just like the F test, where we're looking to see whether or not our substantive model is doing a better job of fitting the data than the null model, which you're looking for 0.05, and so yes we are. We're doing a better job. So this should always be the case, just like with the F test. It should always be the case. If it's not, then your model is really bad. Okay. All right, so the final thing that we're going to do in this video is look at classification of the logit regression. So this really isn't classification like you would have in machine learning. This is just simply, it is a similar thing, but we're not really running algorithms here and doing, again, machine learning where you're trying to predict things or whatever. We're just doing regression here. We want to see how good our regression is doing. All right, so this bit of code is specifically from Jamie Monaghan's 2015 book, Political Analysis Using R. Now, one of the issues with this code is that it won't work if your variables that you're using have different lengths in R speak, or just to say different ends. And so what we're going to do is actually subset the data explicitly here to get rid of that. So we're going to create a new data frame called data2, and we're going to use the subset function, and then I'm going to do data, and then I'm going to use this option where exclamation point is NA. So what that exclamation point means is not. So it's saying not missing. All right, and so we're just going to do this for each one of our variables. There's probably an easier way to do this, a cleaner, more efficient way, but this works. And so what I tell my students a lot is, if it works, right? Like, we could probably find a better way, but at least in the meantime, let's just use this. So we're going to do it for each one of our 4 variables. So we have here employment dummy, gender. Okay, so for each one of these, I'm separating them by using end. All right, is NA, gender, general underscore health. Okay, and I'm going to go down to the next line just to make the code look a little nicer. All right, is NA for this last one here, so marital dummy. Okay, so make sure these are both closed. All right, so we're just going to run that, make sure we have no problem. All right, so once we have that, we're going to steal this line, this code from up above, and just rerun that regression with our subsetted data. So we're going to call this here, just so we don't, you can overwrite the data or the model object. We're going to call this model1b. And then we're going to do data now equals data2. Okay, so let's just run that. We're going to get roughly the same exact results. Okay, so let's actually get into the code itself. So again, this is from Jamie's book, and so there's probably a nicer way to do this. In Stata, it actually is quite easy to do this. But so we're going to do predicted. We're going to create a new object called predicted, use the assignment operator, and then we're going to force it to be numeric with using as numeric, and then predict GLM. So this is just like with the linear regression predict, but predict GLM model 1b. All right, the type we want response. All right, and then outside of this we want to do, we're going to do greater than 0.5. So this really only works with the binary outcome just because we have the 2 values here. Okay. The next line, so that's for predicted. So these are predicted, and then we're going to create a new object that's going to be what we call true, or if you will, observed. All right, so we have true as the object, data 2, and then our outcome variable here, employment dummy. All right, and then we're going to have our correct. We're going to create an object called correct, which is going to be as numeric. We're going to force it to be numeric, and it's going to be predicted, and then double equals true. All right, so these are going to be the ones where to say that. So I guess you could do it. There's different ways to do this, but these are ones where the predicted equals the true values. All right, and then finally we're going to create a table. Oops. That shows how well we did. So we're going to do this all in one step here. We're going to do 100 times, and then simply table. We're going to use the table function, correct, divided by sum, and then table correct. So this is just going to give us a proportion of how often we're correct. So let's run all of this, and hopefully there's no errors. All right. Yay! Okay, there's no errors. If there is, right, all you got to do is go back into the code and check to see what you might have done wrong. All right, so this comes out here, and we see, so 0 means we didn't get it correct. 1 means that we did. So what it says is that our model correctly predicted the outcome 82.77% of the time. Obviously, like, the ideal is 100, but you're never going to get that. So that's actually pretty good. And I've checked this code against the default built-in function that's in Stata, and it's the same thing. All right, so that's it for this video. Again, we looked at just how to get the log likelihood and the pseudo R-squared, and then how to do a classification, a regression classification in LOGIT. All right, so thanks for watching, and I'll see you next time.